Hi, my name is Keren Garcia. I'm a kernel developer for Wolfram Research, and my talk will be on AR and VR using the Wolfram language, where I will briefly talk about how you can use Mathematica and Unity Link to create AR and VR applications. My name is Karen. I'm a kernel developer in the discrete computation team in algorithms department, and I'm going to talk to you guys today about augmented reality and virtual reality in the Wolfram language. So for virtual reality in the Wolfram language, with the release of version 12, we have Unity Link, which allows the Wolfram language to work seamlessly to create Unity components and game objects that you can then use to create virtual reality applications across many different platforms. And so Unity provides the users with the ability to create these VR applications, and I'm going to show you all a video of one that we had made previously. So this gallery was created in Unity using Unity Link. And as you can see, you can walk around in virtual space, and a lot of these game objects that you see here were actually created through Mathematica and then placed into a Unity game scene. But since I have limited time, I'm going to move on to the main purpose of this talk. I'm going to focus more on augmented reality. So as Unity provides support for VR, it also provides support for augmented reality. And I'm actually going to walk us through a demo to building an application. So in this one, you will be able to create an augmented reality scale, so you can scale different objects as well as rotate them in a virtual space. And I'm going to talk a little bit about the requirements that you need to go through. So for this demo, we're going to be building to this iPad. And to build an iOS, it is recommended that you have an Apple developer account, or at least an Apple ID, so that you can build in Xcode. You also need the latest version of Xcode, which you can get at that website. You also need Unity 2019.1.3 or newer, and then a series of different packages that I'll go through as well. Obviously, a compatible iOS device with iOS 12 or newer. And the most important part, so that you can actually build to iOS, is making sure that you set iOS as the build for the platform settings so that you can actually build to it. So some other things that you need for AR is to make sure that you have this camera description so that the Xcode knows that you're actually using the camera for something. Okay, so to begin the link with Mathematica, you need to evaluate Unity Link. And then you can open a project, which this one I've already created. And then this will open Unity in a separate window. And once it does that, we can, whoops, all right. So here is one that I had previously built. But I'm going to go through this process again so that you can see how this whole process went. So once you do that, you can create an asset directory, which is usually how people that develop in Unity organize their content for their games. So I'm not going to evaluate this one because I already did this one. But we're going to create a new Unity scene. So in this case, we're going to call it AR scale. And as you can see here, it's created here. And then in case you didn't believe me, it's right here. So you can set up the scene. And for augmented reality, you need to make sure that you have an AR session and an AR session origin. Because this is what's going to tell Unity that, hey, there's an AR scene, and we're going to place it here. There's going to be an AR camera here. And this is already set. So this comes with one of the packages. So in this case, I'm using ARKit. That is the Apple's augmented reality kit. And so it creates the game objects, as you can see. Oops, sorry. OK, so then we're going to create this AR session. So then you will see them here. And this is really tiny, but there's an AR camera there. So then in the case of this application, I'm going to put a canvas, which is where the sliders that you saw in the previous scene were at. So the sliders are going to have the words rotation and also scale. So that's where you can rotate the actual objects that you're going to put in the scene and also make them bigger or smaller. So as with every Unity scene, you need light, so that's what I'm going to add. And I'm deleting the main camera because there's an AR camera. So you can't have two cameras in a scene. So we don't care about the main camera, we just want the AR one. So then I'm going to create this space where I'm going to put the content. So that's where I'm going to put the geometrical objects that are going to appear in my application. Then you can also manipulate the position as well as the rotation and the scale of these objects. So in this case, I'm going to change the position of my lighting and my content. So now there are some scripts that need to go in this so that the objects know that when you change the scale, you need to make them bigger or smaller, or that you're rotating them. And these are scripts that I've already put in there, so we're just going to find them, and we're going to put them where they need to be. So now I'm going to do the fun part, which is creating the actual objects that you're going to see in augmented reality. So in this case, I'm going to make a spiky, and I'm going to make a revolution plot so that you can see it and walk around with it. So once I do that, they're not going to have any color. So as you can see, here's the scale and the rotation. They're not going to have any color, and that's kind of boring, so I'm going to add some random colors to it. Oh, whoops, sorry. Evaluated this too early. So I'm going to add some color to it, and then I'm going to make them, whoops. And then I'm going to make them go into that content hierarchy that I already built so that it knows that it needs to be in this position. And then I'm going to change the position slightly so that we can see both objects in the same scene. And then I'm going to add Capsule Collider so that we won't actually bump into them in augmented reality. Right. So once I do that, let me see if I can show you this. Once you do that, the entire scene is built, and then we can just save the Unity scene, and we can build it. So once you do that, you're going to get an Xcode project. And again, this is just for iOS. Other platforms have different build settings. So once you get that, you're going to get this Xcode project file, and you click it, which opens it in the latest Xcode version. And once you choose the correct device that you're building to, in this case, the iPad, oops. In this case, this iPad, you're then going to click play, which will then take you to the screen, and make sure that you pick yourself. So in this case, I picked myself as the developer for this. And once you do that, it will build the application here, which I'm going to show you now. Give me a second to plug this in. Okay. So you can all see yourselves, and then here are the sliders that I built, right? So this one is the rotation, and then this one is the scale. So these are the two objects that I made, the spiky and the revolution plot. Now, in the case of this application, there's also a plane detector. So that's all the white spaces that you see. This is the camera actively looking for planes where you can place the object. So if I want to switch it here, I can switch it here. Or I can switch it here, and I can rotate the objects as well as make, as well as make them bigger or smaller, right? And I can go around the room, and it'll detect different planes. So in this case, they are here. And then there will be more planes. Sometimes it takes a while for them to detect because there's like a bunch of different things that it has to take into account. But you can move them around. Again, you can rotate them, and you can make them bigger or smaller, right? And so this is how you can use the Wolfram language to create different, so the models that you can create with Mathematica can then go into something like augmented reality or virtual reality, which we actually have demos of downstairs. Yep. Any questions? Concerns? No?
The white planes that you see, these are being done by Unity or by?
So so the question was about the planes. So these planes are detected by a plane manager that was included in the AR kit package that iOS provides. So that is how those are being tracked. Yes?
You added the capsule collision detection. What exactly is that doing?
So it's just making sure that the objects are not, so, okay, let me see if I can, so that I won't bump into them when I move. Yes. And so that you can, if I had a longer cable, I would be able to walk around the object itself and see it. Mm-hmm. Yes?
Can you go back and forth between doing the programming in Mathematica and doing the programming directly in Unity?
What do you mean by that?
So you could do some of this in Unity and then bring in Mathematica for other parts. So if the assets were in Unity.
Right, so the thing is, Unity Link provides you a way so that you don't have to do a lot of the processes through Unity. You can control them through Mathematica using Unity Link. Yeah, so you can create game objects, you can change the lighting, you can even access some of the other menus. Mm-hmm.
Why are there holes in the spiky?
Holes in the spiky?
The light shines through it, it looks like.
Shadows.
There are holes in the shadows, right? If you look on the white plane.
Oh, right, I see. Well, that probably has to do with the import of the model. You're talking about these, right? Hold on. These right here, right?
I know that it's probably the shadow computation.
Yeah.
So you have to actually optimize it.
Yeah.
This is a baked
Yeah.
ahead of time, but the spiky is actually for
Yeah. I think it just has to do with the baking of the scene, because they're, so this one that I'm running right now is just a development build, so it's not even fully baked. Yes.
Is there similar libraries for Microsoft?
So Unity provides you the ability to build to different platforms. So you can build to like Xbox, Android, and everything. It's just the packages that you pick need to be slightly different. So for iOS, you need the AR kit, which is not compatible with Android, so you would just need the AR core, and I think cardboard as well. Yeah. Yes.
You're moving around in a 3D world in iOS. How does iOS build it?
So this is actually, so the final application is built. So what Unity gives you is an Xcode project, and that project is then built through Xcode. So there's a lot of background stuff that Xcode does in order to build the final project. I'm not sure if I answered your question.
Focus stacking? How does iOS build the world?
So this is just reading with your camera. These spaces are then, you place these objects on the planes that are being tracked through the camera.
But iOS knows what a plane is.
No, so this is actually through Unity. The plane detector is actually something that you put in Unity through the kit that they give you. Mm-hmm. I think somebody else had a question. Yes?
Can you run Mathematica code in Unity?
So you can run, if you use Unity Link, you can use Mathematica code to go back and forth.
So could you, in this moment, be able to communicate with the Explorer?
So in this moment, this is the build. So this was so that you guys could see it live. But if you were in the Unity editor, you could still make changes using Mathematica.